Hello, community. Today we talk about your questions. What are state machines? What are state agents? And state space? So let's go there. Now, state space is really simple. You know, we have been talking about alternatives to the transformer architecture, what we called S4, S5, S6 or Mamba systems. I have 3 videos explaining state space model. We just can use a fast Fourier transformation for the solution of those models that are not including the self-attention mechanism. State space explained. Great. So we are left with what is the state of an agent, an AI agent, and what is within AI a state machine. So let's explore. I have a Hintergedanken, so a thought behind the thought. Because I have here videos where I show you that LLMs cannot solve certain things and where LLMs fail at a context length of 2K. And in this video, I discovered what is the reason for this, and now I'm actively searching for a solution. And I want to see if those models are able to provide a platform to create a solution. Now, you know, at first we're going to look here at the graph structure on a LangGraph. This is the latest development. It started as a LangChain. Now, finally, we have a graph structure for our LLM interactions. And of course, I received questions about LangChain and LCEL. So let's do this in 1 minute. LangChain, the classical old legacy LangChain. What is it? I asked ChatGPT. We have 8, if you want, model building blocks. We have a wrapper, the tool connector, the state management, the workflow, the function calling and execution, the user interface components, debugging, and documentation. Great. If you want to see this here with a code, you know a wrapper, easy. External tool connector for the weather, you know the state management, easy peasy. The workflow orchestration, the function calling from GPT systems, the user interface, your get and post, your debugging, and your documentation. This is all great, but this is all legacy. But let's have a look in the classical LangChain. What is the state of an agent? So, for example, a chat agent here in our context of LangChain here, particularly within a system like the one described, refers to the current information what an agent holds, which influences its decision and responses. So the state of our agent is a dynamic, evolving with each interaction the agent has with its environment or its user. Yes, in the chat agent we have now that it tracks here the conversation history by maintaining a list of messages exchanged during the interaction. That's easy. Understanding now, again, the state of an agent. The state of a system or the state of an agent here is a snapshot of a certain relevant information density at a particular point in time. And for a chat agent, this can include the history of the conversation, so what has been exchanged or said so far, all internal variables or flags that influence here the agent's behavior, or some external data, for example, search results. And the state management is crucial for creating chat agents that can engage in meaningful conversation. So a state, as simple, just the sum of everything that has been said. Give you here a code example here for exactly this. So you have here our chat agent and here the receive message, and you just append here the messages together. In this example, the chat agent class defines an agent that maintains its state as a list of messages. Each message is stored as a dictionary containing who sent the message and the message content. And when the message is received, the agent adds this message to its state, generates a response, and adds this response to its state, and it goes on. A very simplistic model, but now you understand what is the state of an agent. Now, everything changed with LCEL. Because LCEL, or our LangChain expression language here, is now a new declarative way to compose chains. Please note I'm talking here about chains, not agents. So LCEL was designed from day one to support putting prototypes in production. Yes, nice joke. Let's have a look here at the official documentation, and you see here we have our LangChain core functionality, and this is now our LCEL, our LangChain expression language for parallelization, fallbacks, tracing, batching, streaming, async, and composition. And then I would re-rank this. I would then put here LangChain in the middle, because here we have our main two components, the chains and our agents. And then I would put the LangChain community on top of this, where we have the model I/O, the retrieval, the document loader, the vector store, the embedding, and then the tooling for our agents. Beautiful. But the official documentation is different. Now, as I told you, let's focus here on the core idea of agent. And here it is to use a language model to choose a sequence of actions. In a chain, a sequence of action is hard-coded. On an agents, a language model is used as a reasoning engine. Beautiful. Now, chains are something different. Chains refer now in LCEL as a sequence of calls, whether to an LLM, a tool, a data processing step. The primary supported way to do this, to create change, is with LCEL. Chains are built with LCEL. In this case, LangChain offers a high-level constructor methodology. Beautiful. Now, for Ben, for my younger viewers here, a simple example. Let's say you have a customer support application, an AI application. What does a chain do and what does an agent do? A chain in this particular customer support application might be a sequence designed to process a user's query through a series of particular steps. A chain could first do the pre-processing of the text of the query to normalize the language, remove any slang or typos or whatever. And then the chain might involve passing here the clean query to an LLM to generate a response based on a knowledge base. Finally, the chain would include a post-processing step to ensure the response adheres to the company policies, nice, polite, thank you, and so on. Now, an agent in our context is something like a routing agent. Because if this query comes in, you don't know to what department it refers to. Billing, technical support, customer care, or whatsoever. So you need an intelligence that routes this as an agent to the particular department. So this agent here uses a chain to analyze the content, but its specific function goes beyond the sequence of operation in a chain. The agent actively makes a decision based on the analysis and then, in this example, routes the query accordingly. So you see, different kind of operations. Let's make it clear. To distinguish here between chains and agents, LCELs enable developers to create systems that can adapt to new requirements or situations without needing to rewrite their complete founding process sequences. And the agents can be updated or added to handle new tasks, new combinations. Chain can be reused across different parts. An agent can be more and more tailored to handle increasingly complex decision-making processes as the application grows. Now, let me give you an example I find beautiful. So, you're giving a dinner party. This is your project, and you have two main tasks on your list. You have to prepare the food, so the variety of dishes, what we call the chain, and then you have to ensure, because you invite those people, that each and every guest is happy, comfortable. You have a small talk with each and every guest, so you need an agent for an interaction. So let's have a look at this. The chains prepare the dishes. Each dish that you prepare follows a specific recipe, a sequence of steps, ingredients, cooking, and then you end up with the final product. This is a chain in LCEL. It's a predefined sequence of operation you execute to achieve a specific result. Each chain is independent of the guest's personal tastes, or if there are some allergy or restriction, whatever likes. It's about following a recipe step by step to achieve a designed outcome. Chains. agents have a complete different task. They want to ensure that each and every guest is happy. So you ask a friend, tasked with making sure each guest is really enjoying themselves at your dinner party. So this friend checks if anyone is allergic to certain ingredients, prefers maybe some vegetarian option, needs anything special, and based on this feedback, the agents might decide which dishes to recommend to which guest, or if they need to quickly whip up something new from someone that has a very special diet. So this friend is like an agent in LCEL, dynamic, making decisions based on the situation, interacting with the environment, and utilizing the chains you've prepared to solve specific problem. This is important to memorize. So, Ben, chains in LCEL, this is it. Agent in LCEL, this is it. Agents are about flexibility and adaptability, deciding on the fly which chains to use or how to respond to changing scenarios. Typical and task for an LLM. Now, in the new LCEL, in the latest version here, we have only 7 chain constructor. 1, 2, 3, 4, 5, 6, 7. Everything else that you know, everything else that you use up until now, forget about it. Legacy. Plus, those are now the official type of agent. Everything else, forget about it. Why to use LCEL here from the official documentation? Makes it easy to build complex chains from basic components. Does this by providing a united interface. Every LCEL object implements a runnable interface, which defines a common set of invocation methodologies. You know invoke, you know batch, streaming, asynchronous invoke, the classical runnables, possible for chains of LLL objects to also automatically support these invocations. This means every chain of an LCEL object is itself an LCEL object, and LCEL provides a number of primitives. Yes. Basic example, yes, we will have a look at this. So, show you before LCEL and current state. Before, if you just wanted to pass this topic string and get back another string, this was before, this is now, a new language. Batch, you want to run a batch of inputs in parallel, this was the old one, this is the new one. Asynchronous version, before, now. You have to learn a new language. You want to use a completion endpoint instead of a chat endpoint, before, now. You understand? LChat. Different model provider, before, LCEL, with LCEL. Great. LCEL, check. 1 minute, gone. So now we come to the important new function that we have now, a graph theory that we add on top. But where do we add this graph theory? And now here, this community decided the following way, to have a new component here in the LangChain library called LangGraph. And the task of LangGraph is to create more complex LLM application with the introduction of non-DAGs into the runtime. So this means now for the first time, we have now a LangGraph defined cycle function that we can use, and we do not have to build ourselves. Beautiful. GitHub, LangChain AI, LangGraph. And here, just to make it sure, build language agents. Notice agents as graphs. And now the question is, can I use this for my particular problem where all the LLMs fail because of the reason I showed you in my 3 videos? Is LangGraph now a possible solution to this? So, just to be sure, we are talking about agents. And you know what? I told you that agents are classical, here our intelligent LLM system or other system, vision language system, and so on. But now in LangGraph, they make sure, hey, this is not the case, because you can have agents that are much dumber. So An agent can perform several forms of decision-making without directly invoking an LLM, relying instead on a predefined logic, some kind of algorithm, or a rule-based system. So you see, agent can be much simpler elements now that we can put them in graphs and combine them with node and edges and conditional edges and build here or compile here our graph in a runnable. This is important because now this is cheaper and easier to build. So let's show you some non-LLM agent. Rule-based decision making. If you have an agent to detect spam in your email, you might use a set of heuristic rules to classify incoming emails. You can have here specific keywords or the frequency of emails sent from a particular domain. Nothing to do with an LLM, just rule-based. You can have an algorithm to do this, extra algorithm for finding here the most efficient route for delivery. Other mathematical algorithm calculation, whatever you like, that is not an LLM. Or we go with state-based decision making, and you might say, hello, here we have state again. Yes. Imagine you have your smart home, you are leaving the home, and now you want to turn off the heating. So you analyze the current state of the system. This is your flat, your house, your living room. For example, for a specific time of day, let's say from 8 o'clock to 2 o'clock in the afternoon, or depending how many people are in the room or whatever you have predefined preferences. And depending on the state, is it the time? Is there nobody in the room? You have decision making, very simple one. Or you do not have here the intelligence of a large language model, but a simple machine learning model like clustering or topological featuring or anything else. So we have here beautiful node characteristic in our graph for an agent as a graph structure. How does this integrate here now with the LCEL? L or LangGraph is here a library that is built on top of LangChain. It extends here LCEL with the ability to coordinate multiple chains across multiple steps in a cyclic manner. So finally, we have a non-DAG structure we can compose. And the beauty is, the current interface, the exposed one, is inspired by Network X. Now, Network X for 2 years ago, Network X was my bread and butter application. So beautiful that they oriented themselves on something that is really wide known. And LangGraph, you just add cycles to your application. It is not a DAG, of course not, directed acyclic graph, but this is a cycle. Isn't this beautiful? Yeah, there's now this beautiful new revived chat agent executor with function calling. This is now something we simply have to learn the notation. Here we are now at LangGraph, and here this is the base model. This is the simplest Python notebook they provide you here officially from LangChain here. Beautiful, just updated last week. So here we go. How you build now an agent executor from scratch. So setup, okay, yes, okay, you need all of this, you need all your keys, beautiful. And then you create a LangChain agent. So beautiful. So we have our hub. We have now from the agent, we have to create OpenAI functions agent. Then we have here chat OpenAI. Then we have here for the search result. Beautiful. We go here with a GPT-3 turbo version. Yes, beautiful. And then we construct an OpenAI function agent. And you might say, hey, this is easy. This is just a create OpenAI function agent. Yeah. This is now a runnable agent structure in LCEL, in LangGraph. But you know, it is not that trivial, because if you look here at the documentation, we have LangChain agents, OpenAI function agent, base, and create OpenAI function agent. Creates an agent that uses here the OpenAI function calling functionality. Those are the three parameters, the LLM, the tools, and the prompt. Beautiful. And of course, here the chat prompt template and runnable execution. And then they give you a simple example here, what you have to call and how you can create an agent. If you think this is really easy, congratulations. For me, it took some time to understand what's happening here. But just read the documentation. You will find dependables that are just amazing if you start with here this new OpenAI function agent now in LCEL for LangGraph. And if you have here a look at the runnables, this is now a LangChain core runnable based runnable. So it is a unit of work that can be invoked. You notice batched, stream, transform, and composed. You have here this differentiation, invoke or asynchronous invoke, batch or a-batch, stream or a-stream. You have built-in optimization for batch and async, beautiful. And then you have here LCEL. You just can learn this expression and standard methodologies but get yourself familiar because it might seem easy, trivial. However, you know, the devil is in the detail. So now we are back. Now we have here our agent with an OpenAI function. Great. So next we define here the graph and the state of the graph. So now here in our LangGraph documentation, the easiest, simplest documentation we have, we say the LangChain agent has a few attributes, the input, the chat history, intermediate steps, and the outcome. And now what we do, we define here the class here of the agent state. So we have an input, the list of the previous messages, beautiful, outcome, and the intermediate steps. Great. Now we define the nodes in our graph. A few different nodes in our graph. So a node can either be a function or an LCEL runnable. There are two main nodes we need for this. We need an agent that is responsible for deciding what, if any, action to take, and a function to invoke our tools. So if an agent decides to take an action, this node will then execute the specific actions. We'll also need to define some edges. We're in a graph. Remember, network X user interface? Absolutely close. Similar here a UI. Some of the edges are conditional, of course. Reasons that are conditional is based on the output of the node. One of several parts might be taken. Beautiful. So we have conditional edges and our normal edges. Normal, after the tools are invoked, it should always go back to an agent to decide what to do next. Conditional, you get it. After an agent is called, should either A, if the agent said to take an action, then the action to invoke tools should be called, or B, if the agent said it was finished, then it should finish. Amazing. So let's define the nodes as well as the function to decide what conditional edge to take. You have an helper class, beautiful. Then you define your agent. You define the functions to execute the tools. You define the logic that will be used to determine what conditional edge to cool down. And then you have it. So now we put all together and define the graph. And you say, yeah, finally, yeah, of course, you have an endpoint and you have the state graph itself. So this is what you know from Network X. You define a new graph, you say, hey, state graph, agent state. Beautiful. And then, as in Network X, it's the same. You add a node, either it's an agent, or you add a node, either it's an action. And of course, you define an entry point. Now you add for your specific task conditional edges. Beautiful. Then you add all your normal edges with action and agent. And then you're not going to believe it. You compile it, and you compile it into a runnable for a LangChain for LCEL. And this is simply workflow.compile. And then finally, you can ask, hey, what is the weather in San Francisco? And then this is the result. So welcome in the official documentation here, to the basic introduction. I hope you have no problem at all. I have to tell you, it took me some time to get familiar to this new language. Beautiful. Back to the explanations. First step, define the agent state. This was one of the main questions. The main type of a graph in LangGraph is a stateful graph. This graph is parameterized by a state object that it passes around to each node. And each node in its return then returns operations to update that particular state. These operations can either set specific attributes on a state or add to an existing attribute. You might say, amazing. Yes, I know. So whether to set or add is denoted by annotating the state object you construct the graph with. For this example, state we will track will just be a list of messages. We want each node to just add messages to that list. You know this operation. Then you define here the nodes as well as function to decide what conditional edge to take. So here we go. Define the function that determines whether to continue or not. Define the function that calls the model. Define the function to execute the tools. And then the tool executor to get back a response. Beautiful. After this, you put it together. You have here your workflow is now your state graph, your agent's state. And like in Network X, you have some beautiful commands. You have just add the node as an agent, or you add a node as an action. Then you set your entry point, you add your conditional edges. Please have a look at this. And then you add the normal edges. And then you're not going to believe it. This is done. You just compile it. You say app equal workflow.compile. And then you can use it because then it is a LangChain runnable. So, and this is here, what is the weather in San Francisco? And it will go on, it will invoke now the input. You see, this is now the functionality of LangGraph. Now you might ask, is this graph theory application in LangChain really what we were looking for? Well, you have to decide yourself. So for Ben, I know. So I have to do some definitions. A directed acyclic graph. We know this from computer science and mathematics, characterized by its vertices or its nodes connected by edges or links that have a direction and do not form any cycle. This means if you start at one node and you follow direction along the edges, you will never encounter the same node again. Beautiful. So in no way you are in a loop. The characteristics, you're not going to believe it, for a directed acyclic graph, that it is directed and acyclic. Of course, crucial in real fields, computer science, scheduling, data processing pipelines. Or, for example, Git uses a DAG to represent the commits. A very simple example of a DAG. You have to bake a cake. It involves several steps with dependencies. First, you have to buy all your ingredients, the flour, the eggs, the sugar, and the butter. Then you prepare the butter. Then you preheat the oven. Unbelievable. Then you pour the batter into a pan. Then you bake your cake. Then you have to cool down the cake. Then you decorate the cake. And step 8 is to enjoy your cake. So you see, you have here a directed flow. There's no loop back. Because if you have already prepared something, this is it. Now, you might say, but wait a second, we had this multi-agent conditioning even before LangGraph. We have had it in the legacy now, LangChain. Can we build it also in LCEL? Now, before LangGraph, you could have this multi-agent system with multiple rounds of investigation through an alternative design pattern. Yes. So you had modular design, the state management, the sequential execution, and the looping even before LangGraph, but you had to do it manually. Your tools, your integration, custom implementation, everything was done here highly individually, highly manual task. You know the problems that are associated with this. So, example for this, before LangGraph, so without a LangGraph functionality, design separate components of information gathering, agent A, and then the analysis is the task of agent B. You implement a Python script that first called agent A to collect the data from some data store, then store the data in a structured format, for example, in a JSON file. The script then retrieves this data and passes it to agent B for analysis. And based on the analysis, the script decides whether to loop back for more data gathering from the database or proceed to the decision-making phase. Everything was possible beforehand, but now, in summary, while LangGraph provides a more integrated and a more streamlined approach to building stateful multi-agent application with support for cyclic non-DAG computation and complex interaction, developers previously relied on more manual orchestration, external tools for state and workflow management, and custom implementations. And now a third-party app is trying to do all of this for you. Yeah, I asked ChatGPT, hey, can you give me another more complicated example? Beautiful. Before LangGraph. And you have here concept introduction, initial assessment, feedback provision, iterative learning process, the concept of the mastery, the custom implementation for the functionality, the script, yes. And you see, even without a specific functionality by LangGraph for the cyclic computation, the developers in the good old days, 2 weeks ago, could leverage here LangChain alongside other programming and software development techniques to create complex interactive systems. So now, if you were familiar with this, you could do it. Of course you could do it. There's nothing new. It is just that now it is a specific library that LangChain offers here on top of LCEL. What were the pros? What were the cons? And I asked ChatGPT-4 after putting all the information about LCEL and LangGraph into GPT-4. And this is here the response, because I don't want to get into the emotional fighting here of pro and cons. GPT-4 tells us, before LangGraph, the pro, we had a flexibility in design. This personal model approach allows for the creativity of highly customized solution tailored to our maybe sometimes very specific requirement. We had control over the complete workflow. We had a manual orchestration provides complete control over how different agents interact, offer here precise management and use of diverse tools. Now, before LangGraph, we had problems because this manually orchestrating the multiple agent and handling can be really complex, especially in debugging, requiring more code and rigorous testing to ensure that it is really operationally running here smoothly. We had an increased personal development effort, but if you were a specialist on this, hey, it was so easy. Scalability issues here as we grow in complexity, you as a human had to be more and more careful, especially when debugging. So now with LangGraph, what is the pro? What are the cons? The pro is now we have a built-in state management that is simplified for a specific set of tasks here, tracking. We have an easier coordination. We have now cyclic and graph-based nature of LangGraph facilitates the coordination of multiple agents in a more streamlined, predefined fashion. We have a reduced development overhead because this is an operational module. We have to improve scalability, and the graph-based approach ensures a clear and consistent flow of predefined and pre-established information and dependencies between the system. Negative is, now we have some new syntax and a new expression language with some new predefined function that we have to maybe evaluate, define, find out the complexity of it. And yeah, so all developers need to understand and adapt now to LangGraph's way of newly structuring the application. And this not only might require, but this really requires a learning period. Framework limitation. The system design is somewhat constrained by the capabilities and limitations of LangGraph. Any functionality not supported by LangGraph will still need to be implemented personally, externally with LCEL. And for simpler application, if we use here this huge LangGraph, it might introduce unnecessary complexity and overhead. Which leaves me for my personal problem that I decided I need some more advanced methodology to solve here my problem, why LLMs. below a context length of 2000 tokens do not work perfectly. But if you need or if you use LangGraph, maybe examine if this is an option for you. I found, pure accidentally, I found here from Bird Topic here the problem you have in implementing here LCEL runnables. And we are not talking about LangGraph structures. This is from the past. This is from October 2023. And it is such a beautiful conversation. This is the link. I'll leave it to you. Have a look there. Two absolute professionals argue, explore here problems, explore here ways out of the problem that at the current time, the LCEL runnables did not support what was needed by the community. Shows here the fast development process. If you want to see two absolute professional, two geniuses here, finding solution to this, you see here why the open source community is powerful, beautiful, and find solutions that are amazing. The ideas you get working together, you can never have this on your own, or maybe I should talk just about myself. So have a look at this. This is such a beautiful example how open source communities can accelerate this, but it also shows you that sometimes development takes place just because somebody says and calls and says, hey, I need this implemented. And this implementation then is there, but maybe this implementation hinders the implementation of other things. So it is happening real fast. It is real based on a, hey, I need support. I need a solution. And the solution will be provided here for those who are there. But this defines, of course, the whole capability of the system. And if you later come with your problem and your problem has not been standardized and not been already solved for you, you might encounter here problems that you might have to do it manually all over again. It is the same old story. But anyway, this was it. I found out preparing this video, learning with preparing this video, that LangChain or LCEL or LangGraph does not provide the functionality that I'm looking for. And therefore, in my next video, I will introduce you to an advanced methodology that goes beyond LangGraph, significantly beyond LangGraph, because I don't want to have rigid template structures. I want to have compiler that are intelligent themselves, that use here a graph structure to solve problems, but that are learnable in each module. So if you're interested, it would be great to see you in my next video.